All right, let's dive right into this explainer. You've probably heard of the amygdala as your brain's built-in panic button, right? Well, today we're going to completely flip the script on that. We're going to explore how this tiny almond-shaped cluster is actually silently constructing your entire reality. Just imagine for a second walking through life completely incapable of feeling fear. I mean, no sudden drop in your stomach, no urge to sprint away from danger, no heart-pounding panic before a massive presentation. Honestly, it kind of sounds like a superpower at first, doesn't it? But as it turns out, fear is absolutely vital for keeping us alive. And this isn't just some hypothetical thought experiment. This is the literal, everyday reality for patient SM. She's an American woman scientists have been studying nonstop since 1994. Because of a super rare condition called Urbach-Wiede disease, she suffered complete bilateral brain damage that wiped out the specific brain region when she was young. Because she literally cannot feel fear, she's helped researchers unlock just how foundational this tiny structure really is. Her unique case perfectly isolates how we traditionally view the amygdala. Now, looking at the anatomy, it's actually a paired complex, meaning you have two of them, one on each side of your brain, buried deep inside the temporal lobes. They're named after the Greek word for almond, which is exactly what they look like. But treating these two like identical twins? Yeah, that's a huge mistake. Because the division of labor here is just fascinating. The right hemisphere, that acts as your classic alarm bell. It drives fear, negative emotion, and avoidance. But the left amygdala? That one is surprisingly tied to a whole mix of pleasant and unpleasant emotions. It's deeply plugged into your brain's reward system. So they work together, sure, but they have completely distinct, highly specialized day jobs. Okay, so beyond just processing primal panic or joy, this structure is basically a supercharged memory multiplier. See, your brain doesn't just hit record on everything equally like a security camera. Far from it. When you experience something highly emotional, your amygdala jumps in, hijacks your attention, and dictates exactly how securely that memory gets locked away. Picture this. You're walking down a dirt path, maybe totally distracted by a phone call. Suddenly, you stopped dead in your tracks. Why? Because your brain prioritized a curvy branch on the ground that looked exactly like a snake. This all happens way faster than your conscious mind can even process. Your amygdala literally signals your visual cortex to override whatever you were doing, forcing you to focus entirely on that potential threat. So here's the exact biological chain reaction that makes that happen. First, the amygdala detects the stimulus. Then it unleashes a massive flood of stress hormones. Finally, it tags the hippocampus, which is your brain's main memory hub, to lock that fleeting moment down into a lifelong memory. It's like your brain stamping a document with a giant, glowing, urgent sign before filing it away for good. The major takeaway here is that the more a specific moment fires up your amygdala, the more vivid and permanent the memory of it becomes. I mean, think about it. This is exactly why you vividly remember exactly where you were during a major world event, but you have absolutely zero clue what you ate for lunch on some random Tuesday a month ago. Emotion is literally the glue for our memories. Now, we're going to shift gears a bit because fear and memory are really only part of the story. Surprisingly, this little primal cluster is also quietly pulling the strings of your social life. You'd probably assume your friendships are managed by the higher, more rational parts of your brain, right? Well, the reality is it's deeply rooted in our ancient evolutionary hardware. There's this absolutely fascinating study by Bickert and colleagues. They looked at 58 healthy adults to see if this region actually dictates how we navigate complex social circles. The researchers used MRI scans to meticulously measure the exact size of everyone's amygdala. Then, they took that precise data and cross-referenced it with incredibly detailed surveys about the participants' actual day-to-day social lives. And the data showed an unbelievable positive correlation. People with larger amygdala volumes literally maintain much larger and way more complex social networks. And when we say complex, we don't just mean they know a lot of people. We mean they can seamlessly bounce between multiple, distinct friend groups and social circles. And this held completely true even when they adjusted for the age of the participants. So what does this all mean? Well, evolutionary biologists hypothesized that living in big, complicated groups basically selected for a larger amygdala so we could better cooperate, compete, and read all those subtle social cues. In the complex world of primates, you need serious processing power to track who's a friend, who's a rival, and what a tiny microexpression actually means. So the amygdala just expanded to handle the incredible demand. far from just being a panic button, it uses something called appetitive conditioning to help us hunt for rewarding social interactions. Remember that left hemisphere we talked about? This is where it really shines. It learns what brings us joy and connection, and it motivates us to actively seek out those positive experiences. It's literally forging the bonds that hold human societies together. But of course, we have to ask the hard question. What happens to our health when this highly sensitive alarm, memory, and social system goes wrong? What happens when it misfires? Because it's so incredibly central to how we function. Any damage or malfunction here sends massive shockwaves through a person's well-being. When it breaks down, we see severe real-world impacts. We're talking PTSD, crippling social anxiety, bipolar disorder, and even increased risks of binge drinking and alcoholism due to reduced brain plasticity. For instance, brain scans show people with PTSD have a totally hyperactive amygdala response just from looking at fearful faces. And chronic drinking? That can physically damage the area, causing even more behavioral chaos. It gets wilder. Severe stress can actually cause temporary physical DNA damage right inside the amygdala. In controlled studies, exposing rats to acute stress literally fractured their DNA within this specific brain region. It is a stark physical reminder of how deeply stress impacts us, right down to the cellular level. Though, thankfully, the brain is resilient, and by day 7, that DNA had largely repaired itself. And that brings us to the truly awe-inspiring news. Neural imaging proves we are not stuck with a hyperactive alarm system. We can actively modulate our amygdala and heal it through focused practices like compassion meditation and psychotherapy. Studies on Buddhist monks actually show physical, structural changes in this area during meditation. Plus, targeted therapies and certain medications can positively change its size and reactivity. Our brains are wonderfully plastic and capable of immense healing. So, stepping back and looking at how much power this tiny structure actually wields, the sheer influence is just staggering. It's shaping your memories, snapping your eyes toward danger, and even predicting the size and complexity of your friend group. And it's doing all of this before your conscious mind even gets a single chance to weigh in on the matter. Thank you so much for joining me in this explainer. If you're looking to support your body's healing journey, definitely check the on-screen links for Dr. Gangathar's physical therapy and emergency pain relief treatments. But right before you go, I want to leave you with one final provocative thought to chew on. In the end, are you the one controlling your emotions, or is your amygdala controlling you? Keep feeding your curiosity and take care.